A teacher explores the statistical question: how many long division problems can my students complete in 15 minutes? The teacher collects the following responses from 20 students. Complete the frequency table to organize the data values. So the lowest number we have is 3. And the highest we have is 8. We're going to go through and tally each one. And finish this data set. Then we're going to write how many was in each count. So if we had only 2 4s, we would write 2. If there's 10 4s, our frequency should say 10. So go ahead and finish tallying up all of these data values. Lesson 4 is a digital lesson, so if you have access to the Great Minds digital lesson, go ahead and follow along there. Otherwise, just take notes in your workbook as you follow along with the video. It says here are a table and a dot plot of the number of points scored in one game for each NBA team. What is a typical number of points scored by an NBA team in one game? It appears that the majority of the data is clustered or grouped in a clump around 110. But it's not super obvious to see where the center of this data set is because how spread out it is. How would you describe the shape, center, and spread of the data distribution? Well, if I place the center around 100 or 110, you can see that it looks similar on both sides, so I might describe the shape as nearly or approximately symmetric. The center, I would say, is about 110. And then for the spread, we would say that our minimum here is from 92 all the way up to 136. Which is a spread of 44, or a range of 4. And that's pretty spread out. How many NBA teams scored at least 110 points in a game, but less than 120? So we need 110, but under 120. So 1, 2, 3, 4. Nope, just 1. Over 110. 110 or above. Okay. I'm going to shrink this down so I can see them all at once. Here we go. And I'll highlight the ones that are 110 or above, but still below 120. There are 8 NBA teams that scored between 110 and 120. Now it says to complete the rest of the table. So we're going to look at which ones scored 90 to 100. I see 4 that scored between 90 and 100. Now from 100 to 110. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From 120 to 130. I see 5. Then for 130 to 140, there are 3. You said there were 8 teams that scored 110 points, but less than 120 points. A bar for this interval is already created. Now create the other bars. So from 90 to 100, there should be 4. From 100 to 110, there should be 10. You can see that it's raised up to the frequency of 10. From 120 to 130, there were 5. So it's lined up with the 5 on the frequency axis. And then 130 to 140, there should be 3. And we have verified that those are correct. How would you describe the shape of this distribution? Approximately symmetric, skewed to the left, or skewed to the right? If we were to place our center, it might be somewhere around here. So then there's more data off to the right. So we would say this is skewed to the right. Based on the histogram, where do you think the center of the data distribution is? Move the point on the axis to show your thinking. So we're moving this towards the center. And then it says explain. Based on the histogram, how would you describe the spread of the data distribution? It's from 90 to 140, which is a range of 50. Now that range is more spread out than the dot plot because we see that the dot doesn't quite go to 90 and it doesn't quite go to 140. But because we have an interval here of a span of 10, it's going to be larger than 44 because we're not getting the exact minimum and the exact maximum. We're looking at a interval for these values. And those intervals are a span of 10. How many teams scored at least 110 points? Well, 110 or more, there's 8 plus 5 plus 3 points here. So that is 16 teams that scored at least 110. And if we go down this list, we can see 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 that scored at least 110 points. Should be 16 there. Here is a new data set. Which histogram summarizes the data distribution? Well, from 90 to 100, there's only one, so let's check that off. Then it says from 100 to 110, there should be 3 or 4. So 100 to 110, that's 1, 2, 3. But remember, the 110 gets put into this box here. So then for the next section, there should be 4 from 110 to 120. 1, 2, 3, 4. And then we have 2 from 120 to 130. And then it says 1 from 130 to 140. But I'm not seeing any that are between 130 and 140. So neither of these represent this data distribution because there aren't any between 130 and 140. Choose one data display that is not a histogram. Well, this one is not a histogram because the bars are overlapping. Create a histogram of the following data set. So from 90 up to 100, but not including 100. I see 1. From 100, so including 100, up to 110, but not including 110. So 110 through like 109 should go in this section. Or 100 to 109 should go in that section. So we have 1, 2, 3. This one should be 110 to 119. We don't want to include 120 in this section. There's 1, 2, 3, 4. 120 through 129. We don't want to include 130 here. There is 1, 2, and then 130 to 140. I don't see any between 130 and 140. I missed one. Let's go back and look how many are between 120 and 130. 1, 2, 3. Then it says, if the value 122 was added to the data set, how would the histogram change? The bar, or the interval of 120 to 130, would go up by 1. We would change this from 3 to 4 because 122 is in that interval. For the NBA data set, what would happen if the width of each interval was 2? So instead of it being 10, what if we made the interval 2? There's going to be many additional bars, and they're going to be shorter because we're looking at smaller chunks at a time. So you can see the frequencies listed here for each of those. It makes it harder to see what shape the distribution is. In this one, we can see that it is skewed right because it extends farther out to the right. But when we have it like this, it doesn't appear to be as skewed as it does when we have the interval that's 10 wide instead of 2 wide. We can see more specific data values, but with this display, it makes it easier to learn or to view where the center is and what type of shape the distribution has. That's the end of lesson 4. Keep in mind, if you didn't have access to the Great Minds digital lesson, you can take notes on what you've learned in your workbook.